that data is based on how much percentage in functionality of the human genome. Oh, here it is. So
yeah,
what I have here, it is being shown that if a substantial fraction of the human genome is functional, right, aka is not junk DNA, then the evolution of man would not be possible due to genetic degeneration. So in this paper, the author states that human evolution would be very problematic if the genome was 10% functional, but would be completely impossible if 25% or more was functional. Therefore, is that what you're basing the percentage of deleterious versus neutral mutations on?
well, they were just measuring how many mutations occur in the coding regions of the DNA.
Right. But
because the reason most of them are silent is because they occur in the non-coding regions of DNA.
Right.
So that has no effect. Like it doesn't even matter what it is.
I know that's your philosophy and your belief, but the thing is, more than 10% of the genome is functional based on the evidence that we have and we know. Now, he says that human evolution would be impossible if 25% or more was functional. How much of the genome do you believe, percentage-wise, is functional?
Well, the science in this paper, it says about 15 to 20%, I believe.
Right. Now, since there's an evolutionary bias to this paper, and he's literally admitting that if more than 10% is, just wait, I'm not done, just more than 10% is functional, that's going to be very problematic for human evolution. But if more than 25% of the genome is functional, that makes human evolution impossible. Therefore, is he really going to conclude, based on the data, based on the evidence, that more than 25% of the genome is functional? I mean, does that make any sense that he would actually conclude that and come right out and admit that?
Well, the non-coding regions of DNA were not discovered through any process of evolution. It's literally, we just see that these regions are not used by the organism.
So we know that the non-coding DNA, those regions, they function much like a computer, right? They're involved in what? Regulatory functions, which to the audience, for their sake, that just means when and how fast to make specific proteins, which is important, obviously. Embryonic.
Yeah, DNA itself has like several functions.
Right. I'm talking about the non-coding areas that you're talking about, because you're saying they're looking at the non-protein coding regions. So they're also involved in, the timings of protein manufacture, the staging of proteins for construction of molecular machines, switches, for example. I mean, I can go on and on and on and on. Now, when we look at the ENCODE, which I know we have talked about, and, someone like yourself would probably look to spurious transcription, and that's fine. But ENCODE did find that at least, and I'm saying at least 80% of the non-coding DNA was actively transcribed into RNA, which suggests function, right? So that's why we're saying and making the prediction that based on this trajectory of discovery, it seems to at least favor genome-wide functionality. That's why with, say, further, let's say, comprehensive knockout experiments, okay, say on humans, for example, or just mammals in general, there have been some, but not comprehensive tests. I would say that it's premature, for one, to make the absolute claim that the majority of non-coding DNA is non-functional. And I think based on what we know thus far, the trajectory of discovery favors genome-wide functionality. I think it's obvious it's more than 25%. How much more than 25%? Well, we'll see if our, prediction comes true with further research and data. But I mean, I think it's obviously more than 25% functional. What does that say about human evolution?
Well, we know that at least some genes don't have any function, or are at least not used for their functions in an organism. They're turned off through regulation, but that doesn't mean that they have no function themselves as DNAs and RNAs, but that doesn't necessarily mean they get translated into protein. So ENCODE has not actually found anything that significant. It hasn't proven that they get encoded into protein. So, well, and that's the evolutionary definition of the function.
Are you saying that for a gene to be functional, it has to be translated into The protein? I mean, obviously there's other things going on in the genome as a whole. It's kind of like a play. If you look at a play, you got all the actors, the actresses on stage doing what they're doing. Okay? Let's say the coding regions, for example. But behind stage, you got all these set directors, you got all these other workers that are working to make sure that the actors, the actresses, everybody on set is doing their job. They're equally functional. They're all equally in functional roles. So by you saying that if it's not protein coding, I mean, are you saying that roles in regulatory functions, embryonic development, the timings of protein manufacture, I mean, are you saying these aren't important functional roles? And if there's a mutation in a gene sequence such as this, are you saying that it's still absolutely neutral because it doesn't code for a protein? I mean, I don't really understand your logic there.
Well, if it doesn't encode for protein, it's just going to be used for regulatory function.
Yeah, so a regulatory function.
So the sequence doesn't really do anything.
So a regulatory function or a regulatory element is in charge of, you know, how fast, when, for example, to make specific proteins. I mean, that's pretty important. You can look at the phenomenon known as protein moonlighting. I mean, we got these proteins that are doing so many different things. RNA, the literature, you know, back in the day, what is it, the 70s, 60s, 70s, it was known as what, one protein, one gene, one function. So much has been overturned. I mean, the literature on RNA function alone is unimaginable. You know, RNA is doing unimaginable things. So for you to just hold on to your evolutionary philosophy in order to not admit the obvious fact that more than 25% of our genome is functional, and then ENCODE is telling us that over 80% is actively transcribed, what it's all doing, well, it's going to take further research, as I've said, but at least more than 25%, or at least 25% is functional. But you can't actually admit that because it makes deleterious mutation accumulation that much worse for you, and it makes human evolution pretty well impossible. So that's why you have to have this these types of rescue devices, these types of counter arguments that are actually just to defend and secure your evolutionary philosophy. I mean, that's what I'm personally hearing. Go ahead, Snake.
No, it's just that they haven't actually proven any functions for these genes.
Actually, I was listening for a while. I was just muted. That's
Okay.
all.
Do you want to take this one?
Well, with respect to junk DNA, the thing is, the junk DNA doesn't actually mean functionless. It just means it doesn't code for protein. It's just a fancy name they gave it, but junk doesn't necessarily mean useless, because you can use junk.
Okay, so I'm going to jump in there then. So Richard Dawkins, for example, and yes, I'm going to use a quote here. You can look it up. In 2009, what he said, it is a remarkable fact that the greater part, okay, 95% in the case of humans, of the genome might as well not be there for all the difference it makes. Now, okay, after Dawkins realized that junk DNA is dead, and yes, they didn't say it's completely functionless. They said there would be some function found in it, but not nearly as much that has been discovered, okay? That's why people and scientists have been so dramatic and defensive with ENCODE. Okay, so he said, it was in a debate, I think it was Jonathan Sachs, Dawkins stated, I know there are some creationists who have jumped on it because they think it is awkward for Darwinism. Quite to the contrary, of course, it is exactly what a Darwinist would hope for, to find usefulness in a living world. So somebody like Dawkins is admitting that the greater part of the genome, 95%, is junk, may as well not be there. Wow, may as well not be there. Well, that rules out regulatory functions, timing of protein manufacturers, embryonic development. I mean, that needs to be there, of course. But now he's adjusting his position. So are you, emotionally stunted Emoticon, actually going to tell me that this was not a surprise to anybody who knows what evolutionists used to believe? Go ahead.
Okay. So first, I'll just get it off the bat that whatever Dawkins says is not sacrosanct. It's not, it is open to correction. Okay.
I agree. But he's a pretty famous and well-respected evolutionist. We got to agree with that.
He is. In fact, he is. But he's more of a a science communicator. He does more of that instead of actual, writing literature for the.
He did write the book, The Greatest Show on Earth, and the Selfish Gene, though, right? And do you agree
Right,
with?
he did write that.
Well, I want to get this out of the way. Do you agree with the quote that he said in 2009 in his book, that the remarkable fact is that the greater part of the genome might as well not be there? Do you agree with that statement? Let's pretend it wasn't Dawkins. Let's just say it was some random Joe Schmo, whether creationist or evolutionist. He made that claim. What would your response be? Go ahead, brother.
Okay, so but now knowing now that in fact some of the junk DNA have function, I would not agree with that statement. Although it could be removed, and some of it could be removed, and the organism would, the organism won't die. But it doesn't mean that it's not, just because it's not specifically needed, doesn't mean it doesn't have function.
What types of function does the non-coding regions of our DNA have? Like I named a few, right? You were listening: embryonic development, regulatory functions, stagings of proteins for construction. For the list goes on. Like what types of functions, what types of roles do you know of? Emotionally stunted emoticon.
Right. So again, the timing and the expression and so on, all that can be attributed to some of the non-coding DNA.
But aren't they?
Or the junk DNA.
Now, so they're active. They're creating RNA, but they're not coding for protein. Yes. So I know that's technically what junk DNA means, right? They're not coding for protein. But if it's, for one, active in those types of roles, and that it's also active in, correct me if I'm wrong, isn't it active in pervasive alternate splicing, cell differentiation? I think it's even in the non-coding regions that it was found to be active in X chromosome inactivation in women. Am I correct me if I'm wrong on that one?
So I'm not aware of all the functions, but I know that there is a lot of function to be found within junk DNA. But again, junk DNA was never meant to be functionless DNA. We're just meant to be.
I don't want you to straw man, but I know that. But as I showed and demonstrated with Richard Dawkins, they did believe that roughly 95% of it may as well not be there. And you just admitted that you would not agree with that statement, which means you would not agree with Richard Dawkins. And Richard Dawkins didn't just pull that out of thin air. That was a leading thought back before ENCODE and, the accumulating papers and data that we've now discovered. So junk DNA paradigm's been overturned. We know it was profoundly wrong. It's being used in all sorts of ways. So
it's just a difference of how we use the word.
I'm gonna let you guys go as long as you can. I need to ask Emotionally Stunted Emoticon a question. If you have a mutation in the non-coding regions of DNA, and we know the non-coding regions of DNA function in, I'm not going to name them all again, but we can go on for probably an hour. Is that going to be deleterious, detrimental, harmful to that, to the genome?
Well, again, it depends. Not all mutations are deleterious. You can get a benefit. It could be deleterious. It could be fairly neutral.
But so in an area, I don't think you're answering the question. That's the problem. In an area that has roles in, cell differentiation, let's say intronic elements, roles involved in, alternate splicing, regulatory roles, embryonic development. I mean, these are important function and important roles. So if you have a mutation in the non-coding regions of DNA, which we know perform those very important roles, is it neutral? Is it deleterious? Is it detrimental to the point where natural selection is now going to rid the population of this mutant? Go ahead, answer the question.
Right. Again, it could be either one of the three. It could be neutral or, relatively neutral, deleterious or beneficial.
Would you say near neutral? Would you say near new? Like, let's say if it just has a very, very trivial effect on fitness, just tiny, not noticeable to the phenotype. Natural selection isn't going to see it. Natural selection isn't going to rid the population of the mutant because it's not detrimental. It's not detrimental enough where natural selection notices the mutant. But it seems like you had averted to the fact that it might be near neutral, right? It might have a small effect on fitness where it remains. Natural selection doesn't act upon it, but it remains. It doesn't have an effect overall on the phenotype, but here's what Snake and I were trying to come to an agreement on in the first 45 minutes there. It isn't absolutely neutral to the genotype. Can we at least agree on that?
Well, yeah, obviously, once you have a change in it, it's not neutral. It's relatively neutral, but not
relative. Okay,
absolutely.
Relatively neutral, near neutral, relatively the same thing. So
unless it's a silent mutation.
Right. So it's not like, for example, the redundant elements that Snake and I were talking about earlier. The cell uses different redundant elements to slow and speed the process. Right. We know that our genome is highly compressed, and we know that there's tons of papers that talk about how proteins are doing things you wouldn't even expect. Right. Protein moonlighting, for example. So at the end of the day, if RNA was always underappreciated, we know Richard Dawkins underappreciated RNA. That's a fact. And we know junk DNA is decades ago biology, and there's massive literature showing so many unexpected, unimaginable functions in RNA. Is it science or is it pseudoscience to say that the majority of our genome is based on, say, evolutionary leftovers, evolutionary fossils, relics, and that a mutation in a non-coding region, like Snake said earlier, is absolutely neutral? I mean, to me, that's pseudoscience. You just admitted it's going to be relatively neutral, but not absolutely neutral to the genotype, right?
But what about that 20% that has been found to have no biochemical activity?
Let's just say that 20% is absolutely useless. Junk, non-functional. This paper that you brought up, Snake, states that anything more than 10% makes human evolution very problematic. But anything over 25%, the paper states human evolution is impossible. So I'll give you, for the sake of argument, 80% of the genome is functional. That destroys evolution because now the 60 to 100 new mutations per person per generation, that means 80 of them are deleterious or whatever it is. That's horrible. Even if 2 or 3 of them were deleterious and not selected by natural selection, that still is greatly problematic to evolution. You can still hold on to the philosophy, of course, but that type of change.
It's a misunderstanding about
are you saying that
the different ways that function is used? Because ENCODE is using it differently than how most evolutionary biologists use it.
How much of the genome do you believe is functional, percentage-wise?
I think the study says about 15%.
So more than 10% is problematic.
But notice that they're using the word function differently.
Well,
in the different studies.
See, the thing is, though, these evolutionists, they have a bias and they have an adherence to universal common ancestry, okay? So obviously they're going to downplay the results found by ENCODE that at least 80% of the non-coding DNA is actively transcribed in RNA. I'm saying it suggests function, yes, okay? It's preliminary data. But based on the list of things that came to mind that the non-coding DNA is involved in, and I'm sure there's more. If I were to Google it, I'm sure we could find more. The fact is, I think it's pseudoscience to say that only 15% of our genome is transcribed. I mean, just look at the trajectory of discovery. Like I said earlier, back in the 70s, what did scientists think? One gene, one protein, one function. Emotionally stunted Emoticon. He's a smart guy. He probably knows that. Now, so many discoveries. Massive literature showing unexpected function of RNA. Guess what? We're only in 2019. What happens in 2029, 2039, 2050? We are predicting that the vast majority of our genome is functional. Do you believe that is such an outrageous prediction, Snake?
A little bit. but
Why
because
though?
we
If you look,
we have already studied which parts of the genome are functional.
well, how many
Not everything, but
how many knockout experiments on humans have been performed?
no humans, but on mammals.
Right, so it's unethical. So I think it's premature to make the claim that the majority of non-coding DNA is non-functional. I'm going to let you respond. One other thing too is what the DNA is doing on a molecular level, step by step, and the fact that we are just beginning to understand the developmental process, right? How coding and non-coding DNA coordinate, where, when, and how structures are sequentially put into place to produce that fully functional organism, from the embryo to baby. I mean, the amount of activity, the amount of roles involved in that, and we know so little about it. So that alone is probably going to account for the other 20%. But it sounds to me like you have to hold on to your evolutionary bias. I'm sorry to use the word bias, but that's the only thing I can think of as to why you're just ignoring the obvious. You know what I mean? Because I think in one of our debates on MDD, I think I've got it recorded, you said 25%, but now you're saying 15%. Like, why the change?
Well, I think the study says between 15 and 25. 25 is like the upper limit, like the absolute.
Well, I know what the study says, and I know what the study concluded. So therefore, they have to conclude functionality percentage-wise is under 25%. It has to, or else human evolution is impossible. We, as creationists, we can take it to the logical
Coding
conclusion.
regions.
No, you said non-coding regions. Coding and non-coding
No,
combined.
Non-coding would be the majority.
Right. Yeah. The majority is non-coding. Of course, everyone knows that. So the genome-wide functionality. What's the percentage you believe is playing roles? Let's say playing roles, whether it's coding for a protein, involved in embryonic development, stagings of proteins for construction of molecular machines, whatever, just roles in general. How much of the genome percentage-wise do you believe is actively is not idle, is active to some extent? How much?
Well, it doesn't matter unless I'm agreeing to 80%. It's a minority. It's like, it's somewhere under 25%. So
so it's got and that's your philosophy, and that's fine. Okay, it's not science. You have to have it under 25%, of course, no matter what the literature says, no matter how much has actually been overturned. This makes generation that much harder for you.
But that comports with the evidence. It comports with the number of what we've estimated and tested are the functional genes, and I don't think there's any evidence for diseases or problems with mutations in the non-coding regions.
Well, and that's your belief again. But of course, like I said earlier, listen, for the audience, it's good to make it understandable, interpretable. If you have the Bible and you make one single spelling mistake in that Bible, I agree, it's neutral to the Bible as a whole, but it's not neutral to the information content. Okay, it's nearly neutral, as emotional Stunted Emoticon said. It's nearly neutral, but it's the buildup of them. Okay, so let's not bore the audience. Let's agree to disagree on junk DNA. Okay, so the next thing you mentioned was beneficial mutations. Do you believe beneficial mutations can counterbalance the influx, the relentless influx of these deleterious mutations? So whether it's 60 to 100, but then you can debate how many are neutral versus deleterious. To be honest with you, just a few of them being deleterious is still a problem. So for sake of argument, I'll just say a few of them are deleterious. Can beneficial mutations counterbalance the damage?
Well, I wanted to.
Oh, go ahead.
I just also wanted to say that also for the audience, but as well, I think I'm having this conversation at least so we can at least understand each other's positions, not necessarily agree, but just understand.
No, I understand your position, of course. Do you understand mine?
I think I do understand it.
Okay, well, that's good. That's good. So, and you know what, emotionally stunted Emoticon, I want to give you some time too. So